So the first thing we're going to do in this episode is fix one of the performance issues that we actually introduced last episode. For example, if I run the game in its current state, it seems to be moving very slowly around the map. So it looks like there could be a performance issue. So right now we're going to investigate that and fix it. So to see if there is a performance issue, the first thing we're going to do is to print the frames per second that the game is running at. So we're going to go into game and we're going to create a font object because we're going to be printing the FPS to the screen. So that's pg.font.sysfont, none to return the system default, and a font size of 24. Then down in draw, we're going to create a text surface for rendering the frames per second onto, and then we're going to blit that onto the window screen. So we can do, so text surface equals pg, self.font.render, and we're going to say FPS, and we're going to make this an integer, and we're going to get from the clock object, we're going to return the FPS counter. This is going to be false, and we're going to make this white, and then finally we're going to blit this onto the screen. So self.screen.blit text surface, and we're going to put it in the left hand corner, so 1010. Okay, so if we run the game again, we can see how our game is performing, and as we can see it's hovering just over 30 when really it should be 60. So clearly there's some sort of performance issue happening. Now I did some investigating, and what I found was the performance issue is coming from when we are drawing the countries. So every game loop iteration we are iterating through all of our countries and drawing them. So this has to be fairly efficient because we have so many countries to draw, and the problem part of the code is actually coming from the draw text, which was the utility function that we defined the last episode. So if we go into draw text, we can discover why it's performing so badly, and the reason is because we're kind of initializing this font object every time we want to draw some text. Now this really isn't necessary to have this font object initialized inside of this function. In fact, we can initialize it outside of the function and just pass it through into the function as a parameter or argument. So I'm going to instead include it as an argument here, and I can then remove this line of code, and I'll do the same for the multi-line version. So again, we're just going to remove this, and then we need to update the other parts of the code that use these two functions. So back in Geo, we're going to give the country also a font object. It doesn't really matter where you put it, so self.font equals pg.font.sysfont none 24, and when we're drawing the text we need to pass it the self.font. I'm going to do a quick check through my code base to see where else I'm using draw text. We have one version here, that's fine, and another version here, but that's in the world, so the world also needs a font. So I'm going to do self.font equals pg.font.sysfont none 24, and then down in the draw text we're going to say self.font and self.font here. So that seems to have covered all the cases where we're using this function. So we can go back to main, run the game again, and now we can see that we're up to the desired FPS of around 60 frames per second. So that is the performance issue that we needed to correct. But it's also kind of demonstrates why it's a good idea to always have a kind of FPS counter showing whilst you're developing code, and in that way you can kind of quickly identify bottlenecks or performance issues. So also in the last episode we introduced the concept of the different phases that the player can be in, and we initialized this as being able to place units, and then inside the player class that we saw that we had created different methods that corresponded to the different phases of the game. So what we want to work on now is for the game to have some sort of user interface to show what kind of phase the game is currently in. And it's important, one, to show the player what the current phase is, but also a means for the player to move forward to the next phase. So this is what we're going to be working on now. So we're going to be inside the game class again. I'm going to define the 3 phases that we can have. So this is using the kind of same phases that we talked about in the last episode. So that will be, first phase will be placing the units, the second phase will be moving the units, and then finally we have the attack phase, which we called attack country. Rather than having self.phase as a kind of hard-coded string here, what I'm going to use is first have an index called phase index, and because we're going to increment this phase index, and that will be our way for iterating through this list of values. So I'm going to start phase index off as 0, and then we can find phase by taking phases, self.phases, which is a list, and extracting the element that corresponds to the phase index. So just like that. Another thing that we want to do is introduce a phase timer, just to make sure that we don't kind of accidentally click through multiple phases at once. So I'm going to initialize a timer like this. So pg.time.getTicks, and then I'm going to create a new method for creating our kind of phase user interface. So I'm going to define create phase UI, and this is going to return none. And in here we're going to create some rectangles and surfaces to show the player what the current phase is, and one of these rectangles we can click on to move between the phases. So the first surface we're going to create is to show what the current phase is. So self.current phase image equals PyGame.surface, and we're going to make this 200 pixels and 50 pixels. Again, I'm hard coding these values, but you may want to make this a kind of proportion of the window size. That would be better code, but we're going to keep it simple. Then I'm going to color this surface, so I'm taking this kind of bluey color again, dark blue, and we're going to create a rectangle from this. So current phase rect equals self.current image, and we can use the getRect method, and we're going to give it a position, top left position of 10. The next one we're going to create is a button for finishing the current phase. So this code is going to look fairly similar. So we have self.finish.phase image is again a PyGame surface, same dimensions, so 200 pixels width and 50 pixels height. And we are going to again color it, and we're going to give it the same color. Another way to improve this code would be to kind of assign these colors into variables and then import them into the various scripts, but I'm not going to do that right now. And then again we button from this, so that's self.finish phase button is self.finish phase image dot get rect, and top left is going to be 10 pixels in the x direction, but we now want to do it 70 pixels in the y direction because we want this button to appear underneath the current phase button. Finally, I'm just going to have some Boolean variable to say whether we are hovering this finish phase button or not. So self.finish phase button hovered, and we're going to initialize this as false. So we've created a method for this. Now to see it in the game, we need to call it within the init method of the game. So self.create phase UI. And now that we've created our phase UI, we want to also create a method for rendering it to the screen. So we're going to call this define draw, and this is, whoops, this is going to be phase UI self, again returning none. And the first thing we're going to render is the current phase image, so that's self.screen.blit self.current phase image, and we are going to render it in the position of its rectangle, which had a location, so we can just put that rectangle there. And now what we want to do is have a series of if-else statements, because we want to render the current phase inside of this rectangle depending on the current phase. So if self.phase is place units, then we're going to use we have to import it first. So I want to use my draw text function, so that's this one. Then going back down here, we're going to do draw text and pass all the arguments, so that's self.screen, self.font. Because there's place units, we're going to say place, white color, and we want to position it in the center of this rectangle. So we can do self.current phase rect and take the center X position, and we can do the same for the Y, but just using the center Y. And we want to make this to be centered. Yeah. Now what I'm going to do is just repeat this code, but for the moving units and for the attacking. So it's kind of just going to copy and paste it. Going to make these else ifs. Don't think it matters, but it just looks slightly better. This one's going to be move. Of course, we need to also change this. And this one I think was attack country. And this one can be attack. So the other thing that we want to do is now to draw the finish phase button. So this is the button that we click when we're ready to proceed to the next phase. So again, I'm going to do self.screen.blit. This time we're going to take the finish phase image. So that's self.finish phase image, and we are going to give it the location of the rectangle, which was this button. And we just need one call to draw text here, because it's just going to be always called finish phase. So that's self.screen, self.font. We're going to call this finish. It could be finish current phase, finish, whatever you like. I'm just going to call it finish phase. I'm going to make this white, and we are going to again take the center X position, like this, and similar for the Y, and again we're going to put it in the center of the screen, and I'm just very quickly going to check again to make sure that it is rendering in the correct position. Yeah, that looks good. So this is going to be our simple phase UI. Now what we need to do is add some functionality such that we can click on this finish phase and it will update the phase of the game. So for this, we are going to go into the update section of the game. We're first going to identify whether the finish phase button is being hovered, because we're going to change the rendering depending on that. And then the second stage will be if it's being hovered and we click, then we proceed to the next phase. So I'm first going to always initialize or always redefine this hovered to be false. So every game loop we assume it's false unless we meet the logic for it to be hovered, in which case it's turned to true. But this is why I'm putting this here. Then I'm going to say take the rectangle, which is the button, and I'm going to say collide point, and we're going to give it the mouse position. This should be an if statement, of course. So if this button is colliding with the mouse, then we are going to set this hovered to be true. And then in the next part, we're going to say, well, if this is being hovered, and if we click, so that's pg.mouse.getPressed, and it's the first element in this array, or list, whatever it is, that's the left click, and this is where the timer comes in handy. So I'm going to create a now variable to get the current timestamp, and we're going to say if the current timestamp now minus the timer is greater than 500, so that's half a second, then we're going to proceed to the next phase. So firstly, I'm going to reset the timer to be now, which means that we can again click this in half a second's time if we wanted to. And then what we're going to do is we're going to update the phase index and then update the phase using that index. So to do this, we're going to do self.phaseIndex equals, now I'm just going to write the code and then explain it. So we've got self.phaseIndex +1, the percentage sign, then the length of the phases. So just going to quickly explain this. So what we're doing here is we are always increasing the current phase index by 1, but obviously our phases does not have a kind of infinite length. In fact, it only has 3 elements. So as soon as this, because Python you start indexing by 0, as soon as this phase index becomes, let's say 3, we've already gone beyond the kind of length of the list, and so trying to extract that element from the list is not going to work. So what we can do is use the modulus function to basically say, well, when this becomes 3, we're saying 3, and this length of self.phases is also 3, and this is how just modulus works, is that you do 3 modulus 3, it gets reset to 0. So this way we just control or make sure that self.phase index is always 0, 1, or 2, and it resets correctly. So now that we have that, we can do self.phase, self.phases, and I'm going to use this phase index again. Finally, I'm just going to jump back to the draw method, just to give a bit more indication that we are hovering the button. So down here, I'm going to do this over here, I think. Oh yeah, just before we render the finish phase image, I'm going to say if self.finish phase button hovered, then we're going to say self.finish phase image, and we are going to fill this red. I mean, you can choose nicer colors, but this is just a very clear color that we are hovering it. So otherwise, we are going to fill it with the color that we originally set, which was that kind of darkish blue. So like this. I think now we can go back to main and test it again. So yeah, so when we move our mouse over this button, then it turns red. And now if we click on it, we can actually see that we've moved into the movement phase. And again, now we're in the attack phase. And if we press it again, it's going to go right back to the start, to our initial phase, which is placement. And currently in the player class, we only programmed a very basic implementation of placement, which was if we click, then we can increase the number of units within that country. But now if I move to the next phase, which is movement, we haven't actually programmed anything for this. So I'm clicking right now and nothing's happening, because this right now is an empty method in our player class. But this UI seems to be working as we would like. So the next thing we're going to do, well, we're working towards our player having also the ability to move and attack other countries, and at that point it really will feel more like a game. But we have to do a couple of things before we can start programming these methods. For example, for the move units method, we want our player to move units within countries that they control. So firstly, we need to store that data somewhere, the list of countries that we can move units between. But also for attacking countries, we only want to be able to attack neighbouring countries, right? So we don't want France to just be able to randomly attack, let's say, Greece. It should only be allowed to attack the countries that are bordering France. So we need to work on a couple of things now to store these two types of data. Firstly, the countries that we control, and secondly, the list of neighbouring countries that will be allowable attack targets. The easier one of those two is the countries that we control. So I'm going to do that right now, and what we're going to do is just say self.controlled countries is going to be a list, and we could store a list of kind of country classes, but I think it might be easier or slightly cleaner just to store the name of that country. And obviously we control the country that we started off as, so when we start the game, the only country in this self.controlled countries list will be the current country that we began as, so that's why we are including that in the list. Then down in place units, what I've noticed here is it seems that just clicking anywhere in the game is going to increase the units of our own country. Now, we don't want this, we want the mouse to be actually on top of the country that we want to increase the units for. So what I'm going to do is, because we can only place units in countries that we control, I'm going to say for country in self.controlled countries, so this will be a string. I'm going to take the actual country class from the world, so that's self.world countries, and then, because it's a dictionary, we can just extract to the correct country like this. And then I'm going to say if c.hovered and pg.mouse.get, well, it'll be this. Actually, we can just copy and paste this. Then update the timer. This needs a colon. And rather than self.country.units, it's going to be C. Yeah, because it doesn't necessarily need to be the country that we started off. It can be any country that we control. So I'm going to give that a very quick check to make sure it is working. So we should be in the placement phase, and I should only be allowed to increase the units in France, and my mouse needs to be on top of France to do that. So if I start clicking over in Germany, nothing's happening. If I now click in France, I can see that I can increase the units. So that's working fine. Now for neighbours to work, it's a little bit more complicated, or not complicated necessarily, but it definitely requires more code. If we just go back to the map of Europe, we can kind of start thinking about how we want to define neighbouring countries. Now clearly a natural neighbour would be any country that shares a border. So let's take France as our example. We want to kind of look through all the countries in Europe and say, okay, well, which of the other countries share a border with France? So we have like Italy, Switzerland, Belgium, Spain, for example. And so that's fairly clear. So we need some code to be able to identify which of these countries share a border with France. But what do we do for a country like the United Kingdom, which geographically doesn't have any bordering countries because it's an island, but obviously we want the United Kingdom to be able to attack its closest neighbours. So we could have some code for identifying the closest neighbours, or for some of the countries like the UK, Ireland and Iceland, we might just kind of hard code define which countries count as their neighbouring countries. Okay, so this is the code we're going to work on now. So what I'm going to do is start with the identifying the geographical neighbouring countries for each country. So we're going to go back to these polygons and coordinate sets to identify which countries are neighbouring each other. So to do this, I'm going to go into Geo. Yeah, we should be in the world class, and I'm going to create a new method called get country neighbor, get country neighbors in fact. So that's going to be get country neighbors, and what it's going to take is the name of the country, and for this given country, we want to return a list of all the neighbouring countries. So this is going to be a list. I'm going to initialize an empty list here called neighbours, which we're going to return at the end of the function, so I can just do that now in fact. So that's return neighbours. What we can do, which is really useful, is use the polygon again. And the polygon has a really nice method called intersects. So I'm going to say country poly equals self.countries, the country value, and take the polygon. Now I'm going to iterate through all of the other countries. So I'm going to call this other country key and other country value in self.countries.items. Now the first thing we want to do is a simple if statement to check that because this contains all of the countries, obviously we don't want to see if the country intersects with itself. We want to focus on all other countries. So we're going to only do this intersection logic if the other country key is not equal to the current country. So that is if country is not equal to other country key, then we're going to say if the country poly that we've just defined intersects with the polygon of the other country, which we can do like this, then we are going to append this other country to the neighbours list, well, the key. So this is the name of the country. And so we want, this is inside the world class, but ideally we want each country to contain or have a list of its own neighbours. So in that way we don't need to constantly keep referencing this method. We can just calculate it once because obviously the geographies aren't going to change. These neighbours are going to be valid throughout the entirety of the game, so we only need to calculate it once, and then we need to pass this data through to each of the countries. So I'm going to do a method for doing that now. So we're going to do define create neighbours. Self, it's going to return none because it's just going to get these country neighbours and pass them to the country classes itself. So we're going to do for, I'm just going to do this very generic key value in self.countries.items, and then for each of these, so this is the country, this is the name of the country, we're going to do v.neighbours. So v is the country class, so essentially we are adding some more data into here. So this, we could even make it a bit more explicit and say it starts off as having like an undefined neighbours, but here we're actually going to give it some neighbours. So v.neighbours equals self.get country neighbours, and this requires the country string, which in this case is k. So that's all we need. And then we just need to call this when we initialize the world, but it needs to come after this line because we are constantly referencing these self.countries. So here we can do create neighbours. I think what I'm going to do is a very simple print statement here, just that we can kind of eyeball it and see whether the neighbours make sense for each country. So I'm going to say country is k, and this has v.neighbours. So let's see if this has worked. So I'm going to go back to main. Okay, and now we're going to, rather than look at the actual game, we're going to look at the output and just give some of these an eyeball. So yeah, again, what I said before, United Kingdom with this logic doesn't have any neighbours because it's an island, but here we can see like Switzerland is bordering these four countries. That looks legit to me. So this seems to have worked. So our final correction here is to be giving some of the countries like United Kingdom and Ireland, for example, some neighbours. It's totally up to you which neighbours you assign to each country. I'm going to provide these as neighbours, and rather than writing also, I've copied and pasted it, and you can copy and paste from GitHub if you want, or you can assign your own neighbours depending on the country. But this is what I'm going for. Now we have the data available to say which countries are bordering other countries. We can return to our player class, and we can identify what neighbours the player has. Now this is slightly different because the player could control more than one country. So if it only controlled one country, then the neighbours of the player would be the same as the neighbours of that country. But if, for example, the player controlled, well, France and Spain, now the neighbours of France and Spain would also include Portugal, whereas if it was the neighbours of France, it wouldn't. So here we're going to create a new method called getNeighbours, and that's going to be specific to the neighbours of all of the controlled countries. Yeah, and we want to have this as a unique set because I'm trying to think. So let's say if you control Germany and Austria, now they share some neighbours, but we don't want to duplicate those neighbours. We just want to have Switzerland. We have Switzerland only once. So I'm going to say define getNeighbours self, and we're going to return a list. Again, it's going to be a list of strings. I'm going to initialize this as an empty list, and what we're going to do is return the set of this list. So this is just going to take reduce this list to a set of unique values, which is what we want. So to do this, we're going to first iterate through all of our controlled countries. And now, for each of those controlled countries, we're going to iterate through the neighbours of those controlled countries. And if the neighbour is not within the list of controlled countries, we're going to append it as a neighbour. Yeah. Because obviously, if it's a country that we control, it's not a neighbour. It's actually within our, let's say, empire. So then for neighbour. I will spell that wrong. For neighbour in self.world.countries, again, taking the country and then using the neighbours, which we've just defined. And we're going to say if this neighbour is not in the list of countries that we control, like this, then we're going to append it into the neighbours list. And I think that's all we need. And so underneath controlled countries, we can also do self.neighbours. And that's going to be self.getNeighbours. And I think here we just want to do a quick test to see if this is working. So I'm going to print out the neighbours here. But as I said before, if we only control one country, it's just going to print the neighbours of that country. So I'm also going to put Spain into this list. So let's see if this has worked. So actually, I first want to remove the print statement here because we already checked that is working correctly. So here we just want to check whether the neighbours calculation of the player is working. So let's go back to running game. Okay, and so here we can see this is all the neighbours of the player. Now this seems to be working because obviously we have all the neighbours of France, so that's Belgium, Luxembourg, Switzerland, Germany, Italy and the United Kingdom. But now because we've added Spain, we also get the addition of Portugal. So that seems to be working fine.